There are currently over 2,500 active satellites orbiting planet Earth. Of these satellites, more than 800 are used to observe the Earth. This gives us lots of scientific data, which is extremely useful because measurements are made nearly everywhere, so also over areas that are difficult to reach via land. This PhD focused on the impact of using satellite data on hydrological drought forecasts. We're focusing on droughts because climate change will likely lead to more regularly occurring droughts, while at the same time they will become more severe. Accurate forecasts are essential for drought preparation and drought mitigation, and we will therefore take several steps to improve hydrological models over Europe using satellite soil moisture data. Soil moisture is the water content of the soil above the groundwater. The top part of the soil connects the atmosphere and the groundwater reservoir, and soil moisture therefore acts as a kind of regulator for the amount of water coming into and out of the soil. For that reason, we expect large-scale soil moisture estimates to have a large effect on the performance of hydrological models. Soil moisture can be measured using active microwave sensors. This works as follows. The satellite we're using actively emits waves with a wavelength of about 5 centimeters. These microwaves are scattered by the soil. The amount of energy scattered back to the satellite, called backscatter, depends on the surface soil moisture. The more water is stored in the top few centimeters of the soil, the higher the amount of backscattered energy. Using this method, soil moisture can currently be estimated over an area of around about 1 square kilometer. We will try to improve this resolution from the square kilometer to the field scale, so that farmers will be able to actively and regularly monitor the water content on their fields. We will do this by combining active microwave data with optical satellite images, such as the ones you can find on Google Earth. By adding more information to the data, more accurate estimations of soil moisture can be made. The first results of this PhD indeed show that combining different satellite data types is extremely useful for drought monitoring. The second step is to perform a field experiment. In this experiment, we will see if combining different microwave measurements will lead to a further improvement of the accuracy of soil moisture estimations. And hopefully it will also lead to insights in the root zone soil moisture rather than just the surface soil moisture. Finally, the improved measurements will be included in a hydrological model to see whether this has the ability to improve drought forecasts. These improved forecasts will hopefully make it possible to foresee drought events longer before they occur. This will give us extra time to adequately prepare for droughts and in turn help reduce the negative impacts of drought events.